Okay, problem 1-2, part 2. Let's try to show another version of the fairness criterion. So we are asked to show that u of n is equal to 0 if and only if v of 0 is equal to 0. And how do we do that? Well, normally when we show if and if only if statements, we say assume the left-hand side, then show that the right-hand side is true. So that's the implication that goes this way. And then we say assume the right-hand side, and then show that whatever is on the left-hand side is true. And since that's what is always traditionally done, let's just try to do that. So here I will start by saying assume u of n is equal to 0. And then what do we have? Well then, by definition, the integral from 0 to n of e to the delta n minus s multiplied by c of s minus b of s, in parentheses of course, ds is equal to 0 by definition. And I want to make the left-hand side here look as much as v of 0 as possible. So because we have a 0 over here, that makes our life easier. So I can multiply with 0 on both sides. And also I can multiply with e to the, well, I kind of need the n to go away because up here I want minus delta s minus 0, so I kind of need the n to go away. So how do I do that? I can also multiply by e to the minus delta n on both sides because then we have, well, e to the minus delta n multiplied by e to the delta n, they just sort of cancel out, and then we're left with e to the minus delta s multiplied by, no, what I meant earlier was not to multiply by 0, that doesn't make sense. I wanted to multiply by minus 1, because then I can switch the order of the b and the c. So multiply by minus 1 on both sides, then I have b of s minus c of s ds. And it's still equal to 0 over here. And that's nice, because what I actually have now is this thing, which is equal to v of 0. So hence, v of 0 is equal to 0. So we have shown that u of n equals 0 implies that v of 0 is equal to 0. So how do I show it the other way around? Well, to be fair, it doesn't really warrant more calculations, but let's just do it anyways. So we can actually just say, let's assume v of 0 is equal to 0, then we have this, and let's just multiply by minus 1 again, and multiply by e to the delta n instead of e to the minus delta n, and then we actually get back here. So let's just do that for good measure. Assume v of 0 equals 0. Then, by definition, we will have that the integral from 0 to n of e to the minus delta s minus 0 of multiplied by b of s minus c of s ds, but this is equal to 0. And then if we multiply with minus 1 on both sides, and also multiply with e to the delta r on both sides, with to the delta n on both sides, then we have, well, the result. So e to the delta n minus s C of S minus B of S is equal to 0, i.e. U of n is equal to 0, because this over here is exactly U of n. So we're just juggling around with definitions here, but it's still very nice for you guys to know how to show some things are equivalent. So part 3 will be in the next video.